Hello YouTube and welcome to my channel. Today today I'm gonna demo a white noise generator. White noise, pink noise. As you can see right here, I looked up the definition because I wasn't sure what the difference was from one to the other, because some call it pink noise, others call it white noise, but the definition is, as written here on the internet anyway, pink noise is white noise, but with reduced higher frequencies. It resembles the sounds of steady rainfall or wind and is often considered to be more soothing than white noise, which some people find unpleasant. So that's the Google result of the search on that. But it's basically just a noise generating circuit. Then I did a search for that. I did a search for electronic noise generation. And there's tons of schematics on this topic. I mean, I'm surprised how many people have reinvented the wheel with this topic. I mean, there's so many. I see one full page here, using this, using that. It's crazy. I'm scrolling down, you see, and then there's going to be more, but I ain't going to go through all of that. So here's what I came up with. Get the light over here a little bit better so you can see my schematic. I'm using a PNP. It's a 2N5415. Yeah, it's a PNP transistor. It's reversed bias. As you notice, the emitter's tied to ground, which for a PNP that should be positive. And then the base is going to be plus, the base should be negative. So I have a simple voltage divider here with a 1 mega ohm resistor. I have a 10K isolation resistor here, so I don't want to, give too much current to the reverse bias junction and possibly damage it or blow it up. So that's the reason for the 10K resistor, because once this would swing all the way up to 9 volts, I don't want to reverse bias, a reverse bias junction with 9 volts across it. That's not a good idea. That would probably ruin the transistor or open it up. And then with the capacitor here, we're just doing some math, like figuring out what capacitance it was. It turns out to be a 0.1 UF. I believe what's written on it is what's written on it I believe is a 104. So yeah, you put down a 1 and a 0, and then you add 4 zeros, and then you read it in picofarads. That's how you read those capacitors with those numbers on them like that. So yeah, 104 is, like I said, you write it down. 1, you write 10, and then you write your 4 zeros, and then you read it in picofarads. So picofarads, I moved the decimal for the first place. Second place, it's actually 100, I believe it's, or no, I'm not sure on that, how to say that. But it's a 0.1 microfarad. If it were a 0.001 microfarad, that would be that would be 1,000 picofarads. So this is 100,000 picofarads. That's right. That's the right way of saying it. Yeah, 104 would be 100,000 picofarads. These terminologies are a little strange, a little hard to understand, but I'm a little rusty on it because I don't use it every day. But all right, let's get on to the circuit so you can hear it. So I have on my lap here, I have the circuit built on the lab here. You see the transistor and all that good stuff. I'm going to turn it on. And I'm going to turn the volume up on my PA. And as I adjust the control, you can see how it changes the way the hiss, it actually cuts right off. See, you have to fine tune it and find that ideal spot, with the bias voltage. And then as we play with the EQ, you can get all different kind of sounds. You can have it high EQ'd, or you can have it mid-range EQ'd, or you can have it low EQ'd, which kind of sounds like rumbling, kind of like a waterfall or something. Did you hear that? said, depending on the way you EQ it, will depend on the type of sound you get. You can just have the real high frequencies coming through. So there's a lot you can do with it for fun. So that's my electronic noise generator. I hope you liked it. Thanks for coming along. Thanks for watching. Please subscribe, and we'll see you all again later. Bye-bye.